Hello, hello viewers. We want to continue our lectures, our mathematics lectures on circle geometry. And of course, this very topic is a topic that most students find a little bit challenging. And I want to treat it right now. If you have any questions on this, you can contact me. Just comment on the comment section and I will respond to your questions. So I want to begin with treating chords. Chords. And chords are usually part of a circle, that a line that passes, if this my though my circle is not perfect, but lines that touches 2 points in a circumference is known as a chord. Touches 2 points in a circumference. So if I draw a line like this now, I want to draw a line. This is called a chord. If this is my center, that's a chord. Of course, we have the largest chord, which is the diameter, as long as it touches 2 points on the circumference of the circle anywhere. So let's say this is my chord AB. Now, these rules are going to help us to solve some problems on chord. The first rule said a straight line drawn from the center of the circle. Let's say this center is noted as O. Instead of perpendicular to a chord, bisects the chord. A straight line drawn from the center of the circle, perpendicular to a chord, bisects the chord. When we say perpendicular, it means at 90 degrees to a chord. So if I draw a line, straight line, and assuming it passes through the center of this circle, touching this chord, they say it bisects it at an angle 90 degrees. So this is 90 degrees. And this very line cuts it into two equal parts. Cuts the chord into two equal parts. So this line cuts into equal parts. So it's a perpendicular bisector of a chord. Perpendicular bisector, something that bisects a chord, a line that passes a chord, passes through the center. Of course, two of them are invariably saying the same thing. So I want to use it to solve a question now, and I want you to pay very close attention to it. Now I said the radius of a circle 10 cm, the length of a chord of the circles, pardon the way I wrote my circle, is 16 cm. Calculate the distance of the chord from the center of the circle. Calculate the distance of the chord. Now I'm going to, first of all, what we're going to do first is to, first of all, we draw our circle. Then we have, remember we are told to calculate the distance of the chord from the center of the circle. So we draw our chord. So we can decide to label it A and B. And they said that the length of this chord AB is 16 cm. And they said the radius. Now if this is the center, a line that moves from the center to the circumference is the radius. So we have our radius here. Of course, we can also join here if you wish. But we're just going to choose one of the radii. So here is 10 cm, and then we are told this is the line we are told to find, the line joining the chord to the center. This very line is what we are looking for. So I'm going to have here to be A. Now the midpoint, this midpoint, let's note it as C, because we want to take the 90 degrees, a right angle triangle, to work out this distance. So let me say here is, say M. So, and then if here is, and we're talking about a line that bisects the chord, so here is equally bisected. So that means I'm trying to say that A, B, that's the length of the chord. That's the length of the chord. AB is now equal to AM times 2, because of course AM is equal to that's 2AM or 2 times AB, any one, because 2 multiplied, these two are equal, so 2 of it, this one is equal to this one, so I can easily say 2 times this or 2 times this will give me the whole of this. So that is what we have. But what am I driving at? Since I'm taking a right angle triangle, that's the triangle AOM, I'm using it to find that. So it's going to be this direction. So I'm going to draw a line to denote this. So this is AMO. So this is 10. That is so if this is 16, that means half of it is 8. So I have my 8. Then I'm looking for OM. Of course, OM is the distance of the chord. That's the distance of the chord from the center of the circle. The chord from the center. So, sorry, you have not been seeing what I've been doing. So, this is what I've just sketched from here, cropped from here. So this is what we have. So what I'm going to do next now is by Pythagoras rule. So let me say finding OM by, that this OM by Pythagoras rule or theorem. So I'm going to have that OM is equal to the square root of OA minus AM. That means in effect I'm saying 10 squared minus 8 squared. That means I am saying 100 minus 64. Then that will be 36. Then the square root of 36 is 6. Okay. So this is what we have as OM. But remember, we're saying length of chord of the chord is equal to, that is, which is AB, and we say it's equal to 2 times, oh sorry, we're not looking for the length of the chord, we're just looking for the distance. So this is our answer. We're looking for the distance between the center and this. So this is what we're looking for actually. So this is our answer. So feel free to ask your questions. If there's anything you don't understand, I'll be willing to put you through. Thank you.